To evaluate a limit, okay, we can use the first approach is a graph. You can take a look at the graph of the function at the point and find out where the y value is approaching, which we see in section 2.2. We can also take a look at a table. So plug in some number. For example, in this case, limit as x approach 1, you can plug in a number like 0.999 and a number 1.001 to get an idea of what the limit is going to be. But these two approach is just a guess, okay, or an estimate. Now, in order to evaluate or get a limit analytically, we have a few approaches. The number one is direct substitution. So in this case, we just substitute x equals 1 into the limit. So because we're doing direct substitution, okay, so right here, number one is direct substitution. We get rid of the limit sign because we will get a number when we evaluate. So we change x to 1, so 1 squared minus 3 times 1 plus 2 divided by 1 plus 3. Okay, so we evaluate this expression. On the top, we have 1 minus 3 plus 2, which is 0. In the bottom, we have 1 plus 3, so it's 4. 0 divided by 4 equals 0. And 0 in the numerator is okay. The only problem that we will have is when 0 in the denominator. And if you're not sure, use a calculator. 0 divided by 4, you get 0. So in this case, when we do direct substitution, this limit equals 0. Now, there will be case when direct substitution does not work. Then the second approach that we're going to do is, can we factor? So if you take a look at this example, when we calculate limit as x approach 1 still, the numerator is the same, but the denominator now is x minus 1. Now when you do direct substitution, you realize when you substitute x equals 1, x minus 1 will equal 0 in the denominator, and that is undefined. So we cannot use direct substitution. Then we move on to the next step is to see if we can factor. So now we're going to factor, and because we are not evaluating, you keep the limit sign. So limit as x approach 1. On the top, we will factor 2 as 1 times 2. And because the middle term is negative 3, we can factor it as x minus 1 times x minus 2. And you can FOIL this expression to make sure it does give you the original numerator back. Then your factoring is correct. Okay, divided by x minus 1. Now in this case, we can see x minus 1 and x minus 1 cancel. So we leave with limit as x goes to 1, x minus 2. Okay, what it basically saying is these two limit is equivalent because these two functions agree at all points except at x equals 1. So this limit, now we can do direct substitution. We can substitute x equals 1, which will give you negative 1 as a limit. Okay, so this limit equals negative 1. Now that will be the third step when we cannot factor, and we will just use conjugate. Okay, that is when we have radical expression. So if you have limit as x approach 1 again in this case, x minus 1 square root of x minus 1. So we can see, number 1, if we do direct substitution, we have square root of 1 minus 1, 0 in the denominator, so it won't work. We can try to factor, but we see that's a square root of x. So we have to take a look at the third approach, is the conjugate. And that's why it's important that you learn about the definition of conjugate in pre-calculus. So the conjugate of square root of x minus 1. Now the conjugate of this radical term, you just change the sign that's connecting the square root and the number. Okay, so because it's a negative, the conjugate is a positive. So how do we use the conjugate method? So we multiply the top and bottom by the conjugate, which is square root of x plus 1. So square root of x plus 1. What we will get in this case, so it equals limit as x approach 1, okay? Now we leave the term on the top alone for now, because what we're really aiming for is a cancellation. The term in the bottom, square root of x minus 1 and square root of x plus 1. For the conjugate method, we're really taking advantage of the difference of square formula. So when you have a minus b times a plus b, you get a squared minus b squared. So you respect the order, okay? So it's a squared square root of x